Question number 7, make k the subject of the formula. First thing we need to do is expand the bracket to get 18k minus 6q equal to dk plus 7. As we have k in more than one place, we need to make sure that we collect them together. So we bring the dk across and subtract, and then I'm going to take the 6q over here to give me 7 plus 6q. Now the trick here to get just one k is to factorize k out of the expression. It is a common factor, so we end up with 18 minus d equals 7 plus 6q. I can then just divide the 18 minus d as a bracket away from the k. 7 plus 6q divided by 18 minus d. 76 million in standard form. 76 million is the number 76, then followed by 6 zeros. To turn this into standard form, I will need 7.6 times 10 to a power. Has to be a number less than 10, so we make it 7.6. That's where I'm putting the decimal point. It is currently at the end. It has moved 1, 2, 3, 4, 5, 6, 7 places, so it is to the power of 7. Answer the question in standard form. Now, although I have a calculator, this is possible without a calculator. Multiply the numbers together. 8 times 10, and then when we have indices, we add the powers. 13 plus minus 5 becomes 13. Take away 5. So that will be 8 times 10 to the power of 8. Obviously with the calculator, just type it in and ensure the correct answer. A solution to the equation lies between 3 and 4. Use the method in trial improvement to find it correct to one decimal place. So, 3 columns. X values, 2x cubed plus x minus 100, and then whether it is too small or too big. We need values between 2 and 3 and 4 even. And we are going to one decimal place, so 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9 and 4. It's not necessary to do every value, but it makes explaining it quite straightforward. We always check the top and bottom values first. So 2 times 3 cubed plus 3 minus 100 gives us the value minus 43. We are looking for it to equal 0, so this is too small. When we check the value for 4, we find hopefully that this value is too big, and then we know we are in the right area. This comes out as 32, this is too big. Purpose for testing 3 and 4, not only to just check you were typing it incorrectly on the calculator, but also to ensure that the range is correct. The next value we pick is always 3.5, so again we use the calculator to type that in, and we find that that gives us the answer minus 10.75. That is also too small. That in itself tells us that everything in that range must be too small. We need to find something somewhere in between here. I'm going to try 3.7 next, so again I'm going to use the calculator and I'm going to test it with 3.7, and I find that that comes out as 5.006. That is too big, telling me that these values here are also too big. I have to try 3.6 because what I'm looking for is to find two values straight after each other where we go from too small to too big. This comes out as 3.008, so that is too small. This tells me that the answer must be between 3.6 and 3.7. Now they want it correct to one decimal place. To check which answer is correct, I test the value 3.65. It's not acceptable to just say, well, 3.6 was closer, that must be the answer. So I check 3.65. This has to be done to ensure the full marks for the question. So when I try 3.65, I find that this is 0.9, which is too big. Now that tells me the answer must be 3.6. Now the reason this tells me 3.6 is the answer is as follows. We know that 3.6 was too small. We know that 3.7 was too big. We've just checked 3.65 and we've come to the conclusion that's also too big. That means that everything in this area must be too big. Any value within that range, when rounded to just one decimal place, will give the answer 3.6. So we just need to make it clear that the answer is 3.6. Simultaneous equations by algebraic, not graphical method. So that means we can't draw a graph, not that you would try using this question the way it's set out anyhow. I am going to multiply the top one by 5 and the bottom one by 2. I'm going to eliminate the y values. So I will have 35x plus 10y equals 10, and I will have 4x minus 10y equals 68. I now have the same amount of y values, which means I can either add or subtract these equations to eliminate them. If I add these equations, I have 10 plus minus 10, which will give me 0y, which is what I'm aiming for. So I'm going to add the equations. So I'm left with 39x equals 78. So x equals 78 divided by 39, so x equals 2. To find the y value that goes with x, I'm simply going to put x equals 2 into the first equation. So I have 7 times 2 plus 2y equals 2. So 14 plus 2y equals 2. And then I will say 2y equals 2 minus 14. So 2y equals minus 12. So y will be minus 12 divided by 2, which is minus 6. So my solution is x equals 2 when y equals minus 6. Question number 9, similarity. Fill in any values you know. L to m is 3 centimeters. M to n is 2.5. P to r is 3.6. And P to Q is 5.4. Now, from looking at the diagram, I can see that this side and this side are linked. That means that I can work out how many times bigger this triangle is than that one by doing 5.4 divided by 3, which gives me 1.8. So this triangle is 1.8 times bigger than the smaller triangle. If I want RQ, that means I'm looking for the side X. So to find X, I'm going to do the scale factor times by the corresponding side in the smaller triangle. So that is 1.8 times 2.5, which is 4.5 centimeters. Now, if I want to find Ln, which I'm going to call y, this time I'm going to take the corresponding side in the larger triangle and I'm going to divide by the scale factor of 1.8. So 3.6 divided by 1.8. So I find that y equals 2 centimeters. Question number 10. The points A, B, C, D lie on the circumference of a circle. Calculate the length of AD. Now, although this is in a circle, this is not actually a circle theorems question because I have a right angle triangle, so I can use Pythagoras Theorem. H squared equals A squared plus B squared. H squared is opposite the right angle, so that gives me 12.3 squared. A and B squared are the other two sides, so 6.2 squared plus, I'm going to call the side I want x, plus x squared. So I'm going to need 12.3 squared minus 6.2 squared, which will give me x squared. 12.3 squared minus 6.2 squared, so 112.85 equals x squared. So to find x, I'm going to need to square root this number. So the square root of 112.85, which gives me 10.62 equal to the value of x. Right, calculate the area of triangle BCD. Now, circle theorems creep into this question in that you need to know that that is a right angle there. To find the area of the triangle BCD, there are two ways we can do this. Because we have a right angle, we can either find this side, and then use the traditional formula of base times height divided by 2. Alternatively, we can find this side here and use it alongside that side and the angle in between and use a half AB sine C. So I'm going to use the formula area equals a half AB sine C to find the area of this triangle. Now, in order to do this, I need to know both of these sides. I know this side, but I'm missing that side there. So I'm just going to call this side y for the time being. As I have a right angle triangle here, I can use trigonometry. This is the angle I have, which means this is the side opposite. That's the right angle, which gives me hypotenuse here, leaving me with y being the adjacent. I am looking for the adjacent and I know the hypotenuse. That means I am going to have the formula cos theta equals a divided by h. So in my triangle, cos 41 equals a, that I'm trying to find, divided by 12.3. So cos of 41 times by 12.3 gives me 9.28 as the side y. I can now apply the half AB sine C formula, which is a half times by this 9.28 I've just found, times by the 12.3 I already know, as these are the two sides, times by sine of the angle in between. I can type all of this into the calculator and find the area of that triangle. So I find that the total area is 37.44 and it will be centimeters squared. Question number 11. There are 100 pupils in year 8. Find an estimate for the median of this distribution. So if there are 100 pupils, the median, the middle pupil, will be between pupil 50 and pupil 51. Because if I were to list all 100, I would ignore the first 49 and the first 49 and the last 48 either side, and I will be left with pupil 50 and 51 because I've ignored 49 either side, leaving me with these two values. So the first 10 pupils are here. At this point we are up to 26. At this point we get to pupil 50. So pupil 50 will be in this group and pupil 51 will be in that group. Therefore, the median would be in between. Now it is reasonable to assume that the last person in this group is fairly close to 30 and the first person in this group is also fairly close to 30, so we can make an estimate that the median would be 30 seconds. Draw a histogram. Now to draw a histogram we need to work out the frequency densities, and that is found by doing the group width divided by the frequency. So we get 1. Again, frequency divided by the group width divided by the frequency, and we get 1.6. This one we're going to get 2.4. Here we're going to have 4.2. Be careful here that this group is 20, so we have to divide it by 20, which will give us 0.4. And then we are going to plot the groups against their frequency density. So between 0 and 10 the frequency density is 1, so that's going to give me a bar between 0 and 10 up to the height of 1. The frequency density goes up to 1.6 between 10 and 20, so my next bar is going to go slightly higher to 1.6. My next bar will go up to 2.4, which is between 20 and 30. The next bar again then will go up to 4.2, which is between 30 and 40. So 4.2 is here. So between 30 and 40 we're at 4.2. And then my final bar between 40 and 60 is only 0.4, so that will be the entire remainder there between 40 and 60 at 0.4.